Hi all. Hi all. So in this video we're going to discuss about tensor operations and TensorFlow. So we're going to import required libraries which are TensorFlow and NumPy and set seeds to ensure that our results are reproducible every time. So we define a scalar, a 1D vector and a 2 by 2 matrix. So TensorFlow's tf.const lets us explicitly set the data type. So these are the results, and moving on to checking the shape of the tensor. So we can use dot shape and dot d type and dot ndim to inspect the structure and properties of tensors respectively. Tensor casting and arithmetic. Casting basically changes the data type. Then we do element wise addition and multiplication just like NumPy. Reduction and matrix operations. So we can reduce across tensor axis or perform matrix multiplication using tf.matmul. Moving on to transpose, norm, and concat. Transpose basically flips rows to columns and columns to rows, and whereas norm gives us the Frobenius norm and concat stitches tensors end to end. So these are the outputs. And moving on to stacking, stacking tensors, expanding dimensions, and squeezing dimensions. So basically, stack adds a new dimension, expands, squeeze changes shape without altering the data. Moving on to stat and softmax. So reduce and reduce mean get summary stats, and softman turns the logits into probabilities. And moving on to linear algebra, so the matrix determinant, inverse, and trace are essential for solving equations and analyzing matrices. More of the matrix operations like tf.rank, which returns the number of dimensions, and also the element-wise division is done by slash operator, forward slash operator. Eigen decomposition and Cholesky. So use Eig function for symmetric matrices to get eigenvalues vectors, and Cholesky is a fast decomposition for positive definite matrices. Moving on to SPD, exponential and log. So SPD is the backbone of PCA, therefore the principal component analysis and recommendation systems. We also show element-wise exponential and log operations. Moving on to cosine similarity and QR decomposition. So basically the cosine similarity measures directional similarity, whereas the QR decomposition is useful in linear least squares. So moving on to log date and batch matmul. So log date is useful for numerical stability, whereas the batch is used for multiplies to multiply the matrices in batches, which are usually great for deep learning. ReLU variance and standard deviation. So ReLU zeros negatives, whereas variance and standard deviation measure the spread. So generally normally distributed or truncated normal values for simulation or weights. So the Hadamard product is nothing but element-wise multiplication. So contrast this with matrix multiplication. High-dim matrix operation. So the high-dim matrix multiplication works the same just with bigger sizes. So the transpose, inverse, and determinant. So the transpose changes the axis order, whereas inverse and determinant apply to the square matrices commonly used in solving linear systems. More of metrics and Similarity. Logit can fail on non-positive definite matrices, whereas quotient similarity is often used in NLP and recommendation engines. So we finish with the log transformation and ReLU function, therefore, which are the standard tools in every ML pipeline. So these, to wrap up, these are the tensor operations. We have used TensorFlow to execute them. So the various operations like tensor creation and math operations and linear algebra decomposition and broadcasting in TensorFlow. Thank you.